Bismillahirrahmanirrahim. This is part 5 of lesson 5. In this part, we are going to create this exercise ourselves. In our previous part 4, we discussed this exercise in very detail, performed all the portions of this exercise. Now we will create this exercise ourselves in order to further practice. So this is an additional activity and this is not the part of LabVIEW 1 training, but this can be a little bit challenging exercise to test yourself. Let's start. We create a while loop here, create a control terminal to this while loop, this star button. Alright. We create a case structure in this while loop. Alright. And then we go to waveform, go to analog waveform, go to generation, and we get a sine waveform here. Similarly, we go to waveform, analog waveform, generation, and get a square waveform here. Now this will result in a waveform data type, but we want to get only waveform component. For that, we get a waveform component. Get waveform components. And we connect it here to waveform components. Alright, we drag it to here. Okay, similarly, we copy this and we get a waveform component from here as well. Also take this waveform data type so that we can use if we want. Similarly, take this square waveform component here, waveform component as well as waveform data type, which contains additional timing information as well. Alright. So after this, we need a tape control. So go to modern, go to containers and pick up a tape control. So this is a tape control. You should change its position, size, resize it as per your need. Let's perform first of all concatenate channel operation. Concatenate channel operation. Alright. Create this tape, click this tape control with case with this case structure in order to use this concatenate channel operation. Alright. Then go to array, get a build array function, resize it to 2 nodes, connect it here, sine wave and square wave are taken, and after that you need a waveform chart, waveform graph on this to see the result. So this is the waveform graph to see the result. Let us remove this auto scaling and set from 0 to 2000 and amplitude from 0 to 5. Alright, okay. Or maybe the amplitude may be from minus 5 to 5. Okay. Connect it to waveform graph here. Now we need to concatenate this in order to see resulting 1D array. Now if the concatenate input is not activated, then it gets a 2D array. We want to see 1D array, we want to concatenate both 1D arrays, then click this input. Now it is concatenated and here we see concatenated data. Name it concatenated data. If suppose you want to also see array of this concatenated data array, so get an array of numeric and then extend it. Go here and connect this array here. Now run it to test it. You see this is the expected operation and results are as per our expectation. Alright. So okay, let us move to now another operation. Add subtract channel. Okay, we stop it and we change its name to add subtract channels. Alright. So here we move to add subtract channel and then we create a case structure here and create a control here. Name it subtract. Alright. So if this subtract button is true, then we want to subtract the sine waveform from this square waveform. So go to numeric, pick up a subtract function and subtract sine wave from this one. Copy this waveform graph and array, paste it here and then connect it to graphs. Also connect it to here. So this is 8 subtract channels and this is basically 8 subtract data array data. Alright. If this is false, then sine and square should be added. Alright, now this is complete and let us test this. Okay, run it You see, this is now signals are being added. Now the sine and square are added because this is false. When subtract is true, sine wave is subtracted from the square wave. Alright, stop it and then create another tape for the operation of select a channel. Alright, right click here, go to add page after and create a page tape, select a channel. Alright, here right click and add case for every value and go to select a channel. In select a channel, first you should select a build array and then take one sine wave, square wave and then take one function of index array. Because you want to select a channel, either you want to select a sine wave or square wave, or either channel 0 or channel 1. So pick up the index array function, connect here and create an enum. Create an enum. How to create an enum? For this, we go to enum and take this enum silver. Right click, edit it. So you have two options, either to select channel 0 or to select channel 1. Change the name of it to select channel. Alright. So connect it here with the select channel. Index should be connected with the select channel. And then copy again. Alright. So when select a channel this operation, this build array will basically combines the sine and square waves into one 2D array, and this index array extracts row 0 or row 1 from 2D array. Alright, and then we need to pick this graph here, like here, and change its name to single channel of data because it will extract single channel, this index array. Connect output with here and also copy the 8 subtract channel from here, this data array, paste it here, alright, and rename it to single channel of data array. Connect it here and then simply put it here and place graph here. Now run this single channel, select a channel data operation and see the results. You see, for now channel 0 is selected, and when you click it, then channel 1 is selected. So this is how you select a channel, a row using index array. function. Alright, stop this vi and then move towards another tab, create another page, 8 page after, name it waveform data. Alright, go to block diagram, add case for every value, go to waveform data, and in waveform data, now we will get this waveform data type. This waveform data type is a special kind of cluster that contains additional timing information about the waveform. So pick up a build array, sine wave, square wave. This creates a 2D array. Okay, on this square wave perform an operation add offset. Okay, here pick a vertical fill slider, resize it, name it offset, add this offset here. Alright, and then give to build array, and then copy this channel of data, paste it here, rename it waveform data, connect it here. Alright, after that go to the front panel, pick up this waveform data graph here, and then run this CI. Alright, we do not see proper result here, let us see why. Offset is added here. Alright, let us check here if output is coming. Yes, this is working fine. Yes. Alright. Yes. Actually, we need to auto scale here because now you see that as I already mentioned that this is a waveform data type, and this waveform data type consists of also additional timing information, and time is up to 1 second. Therefore, when you auto scale x and y, you get now properly results. And here, if I can change y scale and make it from 2 to -2 to see results, and if I you see it now offset is added here. To further observe the offsets, we can make it from 10 to -10 value. See, this offset can be observed. Alright, okay, stop it and then go for the next step. And in next step, we perform all data channel operation. Right click here, add page after, name it all data channel. Alright. Similarly, right click here, 8 case for every value, go to all data channel, and there you should pick up a build array. Take a sine wave here, square from here. Alright. Further also add offset here. I mean the same code like previous part. Copy the offset from here. Alright. Connect it here. Alright. Similarly, the, copy the waveform data from here. Paste it there to see the waveform data. Okay. Now connect it to here. Alright. We can perform this operation in another way as well using for loop. Pick up the for loop, pick up this square wave data and give it to build array. Alright. Rather, rather also do the same coding. I mean, copy this of add function and also insert the offset. Alright. Click here to second input. Alright. Take sine wave from previous point here, and when you copy this, now on these both graphs you should see the same waveform. Same waveform should be there on these both graphs. So these codes are equivalent. Let us test it. This is the offset. Get this sine waveform data here. Take this waveform data there. Now run it. You see same waveform on both of the graphs. Alright. Okay. Let us move ahead and perform our last step, which is waveform subset. Right click, add page after, go to waveform subset, go to block diagram, right click, add case for every value, go to waveform subset, then pick up a build array, and then pick up array subset, connect this array subset here. You should select both of the rows, so index should start from 0 and length should be 2 because you want to extract both the rows. Alright. Now you should give start value from where the data should be extracted and length up to what data should be extracted for these both rows. Therefore, I go to front panel, I go to numeric, I pick one vertical point slider, I make data from 0 to 1000 and I name it start value. Drag it as per your need. Copy it, paste it here, name it length, connect this starting point here and length here. So this array subset will return a subarray from n dimensional array. Okay, portion of array. It is starting at intakes and containing length elements. Alright. So similarly, at the waveform graph here, this is basically subset data. Name it subset data. Here you are going to get 2D array basically. You see this is a color of physical appearance of 2D array. So for that purpose, create a 2D array this on this front panel as well, or copy it from somewhere. Copy it here, paste it here. All right, and then add dimension here and drag it from here. And then name it basically subset data array. Connect it here. All right. Okay. Now you can run it. Select length 1000. Initially start value 0. Make these values default values. Going to data operation, making current value default. Making current value default. Now you see it shows complete 1000 elements, but if you want to reduce the length, you can reduce. Now it takes only almost 800 points. Similarly, you can change the length. You can make this subarray from the main array. You can extract the subarray as per your own need. You can also change this start value. Alright. So thank you very much. This was additional exercise that we created ourselves. So you can test it on your computer as well to further practice and get expertise on LabVIEW. Thank you.